Hello and welcome. So we have this function applied to 3, and the question is how many digits approximately do we have here? Well, let me explain what this f3 is. So f3, we want it to be a strictly increasing function, and so the input here is a 3. So this 3 here is going to tell us how many times to repeat the function. Well, we can't repeat the exact same function because it's strictly increasing, right? So if we're just f3, f3, f3 applied to 3, that's going to lead to a contradiction that's going to be growing faster than itself. That doesn't make any sense. So we'll have to repeat a slower growing function. Let's call it f2, okay? Well, now how does f2 behave? And by the way, this is f2 of f2 of f2 of 3. I'm just not putting the parentheses because you don't need parentheses, right? You don't need them. Not in this case. It's clear what we're doing here. So what is this f2? Well, the 3 again tells us how many times to repeat the how many times to apply the function, but again, we can't apply f2 3 times. We'll have to go 1 down to f1, like so. And then, again, the same thing. We have f2 of f2 of f1 of f1. This 3 fed into this f1 means that we're going to apply a function 3 times to 3, but not f1, it'll be f0. And then we'll think of f0 as we've hit the bottom. We've hit the bottom, right? We're not going any more, we're not going to f-1 or anything like that. We've hit the bottom. Now, what does f0 do? Well, it's going to be a strictly increasing function. It's just going to do something very simple. It's just going to add 1, okay? So f0 of 3 is 4, f0 of 4 is 5, f0 of 5 is 6. So this is going to be f2 of f2 of f1 of f1 of 6. Well, now our input has grown at this point. Now it's a 6, right? So now we're going to have f2 of f2 of f1, and this 6 tells us to repeat this function 6 times. Well, repeat the function, demoted 1 step to the f0s of 6. And then this is going to be f2 of f2 of f1, and then 6, adding 1 6 times to it is going to give us 12. So that's how it works, right? I think it's clear how it works now. So then the question is, how many digits approximately does f3 of 3 have? 5, approximately 100, approximately 100 million, or way, way more than that? Well, let's see. So f0 of n is just n plus 1. F1 of n is going to be f0 applied n number of times to n, which means we're adding 1 n number of times. So n plus 1 plus 1 plus 1 plus 1 n times, that's going to be the same thing as n plus n, which is 2n. So f1 just takes the input and doubles it. That's what f1 does. What about f2? F2 of n is going to be f1 applied n number of times to n. And f1 applied n number of times. Well, what does f1 do? It just doubles, right? So this is n times 2 times 2 times 2 times 2, n number of times total. So we're taking n and we're multiplying it by 2 n number of times. Okay, so f2 is basically just repeated doubling of n, n number of times. Now f3 of n gets a little bit harder to explain because we're going to have f2 applied n number of times, of course. So let's think about what this is all about. So f2 of n is 2 to the n times n. So f2 of f2 of n is going to be, well, think of this as the blank. So it's 2 to the blank times blank. Now we have f2 of 2 to the n, which means if this is I don't know, this is the what's a cool like animal, like I don't know, a sloth, right? So we're gonna have 2 to the power of a sloth times a sloth. So that's what applying f2 twice does. Now if we apply f2 3 times to n, now after applying f2, we get this whole thing is going to be the sloth. So we're going to get 2 to the power of the sloth, and then times the sloth. It's kind of cool, right? You get this like fractal pattern as you write it down, right? Which makes a lot of sense because we're doing a lot of recursion. So yeah, it kind of makes sense that we're going to get a fractal pattern out of all this. So f3 of 3 is going to be f2 of 3, which is going to be f2 of 2 to the 3 times 3, which is going to be f2 of 2 to the 3. Oh, I'm sorry. That's which is going to be 2 to the 2 to the 3 times 3 times 2 to the 3 times 3. And then finally, oh, and then f2 applied to all of that. Okay, sorry, I'm getting really messy here. Let's slow it down, okay? So we're gonna get 2 to the 2 to the 2 to the 3 times 3 times 2 to the 3 times 3 times 2 to the 2 to the 3 times 3 times 2 to the 3 times 3. Did I get that right? So how many digits does this thing have? Approximately 100 million digits. Oh, but I did have that one option that said way more, and I put it in red. So am I just throwing a little bit of deception, so to speak? Yeah, a little bit. I don't want to make it too obvious based on, oh, you know, it's always the last one. However, I'm not gonna cheat you out of the last one, because if instead the question was what is f3 of 4, then the answer is it's way more than 100 million digits. Is it a trillion, a quadrillion? Oh no. It would take like, I don't know, I'm not gonna be precise here, but like 1,000,000 pages just to write down the number of how many digits it has. Something like that, right? Something on that scale. If you know about Graham's number, if you have f omega of n, if you define this to be f sub n of n, and then f sub omega plus 1 of n is just going to be f omega composed n times onto n, then f omega plus 1 of 64, that's going to be sort of like at the scale of Graham's number. In fact, this is going to be, you know, a bit bigger than Graham's number, but basically in the same ballpark, right? And why does these things grow so fast? Well, I like to think f3 is a repetition of a repetition of a repetition of adding 1 a bunch of times, right? Actually, that's a little bit I might want to reword that actually, because that could actually make you think of something that grows much slower. But yeah, so I might make some more videos on this kind of thing, because it's pretty fun. There is some serious math kind of like lurking in the background, but at this point it's just kind of like, oh wow, recursion, you can like build big numbers, you know. Well, big numbers is not really because you can get any number by just adding 1 enough times, right? What's really more fascinating is fast growing sequences of numbers, right? That's what it's really all about. So it's not so much about you know, f3 of 3. It's more about f3 itself, like, oh wow, f3, you know, it grows pretty fast, right? That's the really kind of but of course you just feed a number to it, like 100, and then you say, oh wow, I've got a really big number, right? So if you have any questions about any of that, feel free to ask. Hope it was fun and interesting, and yeah, take care.